In this video, we'll be covering the concept of the area of a trapezoid as well as the application of the area of the trapezoid to approximate the area under a curve. So, this allows us to consider the fact that most trapezoids will appear in some form like this. This is the most common version of a trapezoid. Again, it's got two parallel sides that are uneven and two non-parallel sides. Now, these two parallel sides are generally referred to as base 1 and base 2. And then we have some value here that determines the height. So the area of this trapezoid, or any trapezoid that looks like it, will be the area is equal to base 1 plus base 2 divided by 2. In other words, basically what we're going to do is we're going to slice this down the side here and here. We're going to take this piece over, we're going to move it over to this side so that the bases are averaged out. So they're not necessarily base 1 or base 2, but the average of those two bases. And then we're going to take that value and multiply it by the height. Okay, I have it labeled here as h1, but it doesn't really need to be labeled as h1 because we, again, only have one height. But this is the area of any given trapezoid. Now, the question is what happens if I were to, I don't know, flip this trapezoid on end in some form or another so that it has, again, still two parallel sides, 1, 2. It's got two uneven sides, again, this one here and this one here, where this value distance right here is obviously the so-called h from back here. So I'm going to relabel this particular trapezoid so that instead of having B1 and B2, I have H1 and H2. And this distance right here is obviously my base value at this point. So if I were to look at this trapezoid, again, base 1 and base 2, and divided by 2, so I'm going to, in this case, have height 1 and height 2. So this is equal to height 1 plus height 2 divided by 2. And I'm going to go ahead and multiply that by the base, in this case. So you'll notice that if I were to have, I don't know, some interesting curve coming through here, this might be an actual really accurate approximation of the area under the curve in that section. And then we could also make some more of these trapezoids where they approximate the area under this curve relatively accurately. Now keep in mind the area of a trapezoid does eventually, if it is perfectly straight level across, become the area of a rectangle. So this is the concept for what we call the trapezoid rule, where if we add up enough of these intervals, we will end up with this little formula here. Okay, and the comparisons that you need to make is my base is nothing more than delta x. Again, all of these bases here, base 1 and base 2 and base 3, as I consistently find different rectangles, that's nothing more than the delta x in this formula. Then you'll notice I have f of xi plus f of xi plus 1. So those two pieces right there are simply the different heights at each different location. Okay, so I have height 1 here, and I have height 2 here. If I average the two heights together, again, divide them by 2, that's the 1/2 sitting out here, then that provides me with my, that times my base gives me my area of those trapezoids. So this formula should make sense to be simply evaluating the addition of n trapezoids of these areas.